And I'm live. That is pretty cool. Today is 19th of April 2026, Sunday. And let's start programming. Yep, we have to fix some bugs. The website is online. You can go to walrus.codes. The website is there, but there is a problem. That is, it is trying to reach localhost, which it should not. So yes, there is a problem. Even though here, when we are building in our CD pipeline, here this is building the backend image and pushing it. This is this is building the other image. Cool. And then we log into Docker, then we start building, but we are not giving here the architecture, the target architecture. Platform, I think, is the name. Platform, Linux, AMD 64, something like this, which does not work here. But yeah, we are building the back end, the front end, which is Nginx production, but that is not building Nginx production properly. Why? Nginx production, in Nginx production we get the index.html file, we get the whole distribution, we copy it, and we get a normal like basic index.html file which should be served at a specific place, and then the Nginx configuration, and we are getting this built frontend from frontend production. And frontend production runs this command: bun run build production. And bun run build production is defined here. Bun run build production builds this, runs this command: bun run filter in the front end monorepo, inside the front end package or app. Run this command, build production. And if we go in apps front end package JSON, there is this command, build prod, means white build, and the mode is production, PRODUCTION, production. And when we do this, then env dot production is going to be taken up, which means Sadaharu underscore backend should be taken up, but it is not. Instead, we are getting localhost. We are not getting this. Why are we not getting this? Is it no, because of git ignore? No. PRODUCTION, production. Backend URL should be this: backend Sadaharu. Backend API URL is this, which we get in here. Sadaharu backend API URL, and then we are logging it. That is why we are seeing localhost there, but we should not be seeing localhost. Hello, always remember that you are absolutely winning just like everyone else. Of course. Wait. Oh, that is a good one. That is a good one. And hello, Keshavai. You did something bad. Shit. Like chat. Cool. Shit. This is a cool one. Shit, but who said this? Who's the source? If you are the source, then that is very impressive, but I don't think so. Just like, yeah. Got the source. Margaret Mead. Oscar Wilde? Margaret Mead. Who is Margaret Mead? She's old. When she was old, now she's dead. Okay, she has written some books. Cool. Yeah, it seems like so. And this, we are not getting the correct URL. Base URL. But in that case, why are we getting localhost as a URL? We should not be getting anything in this. Yes, this is like something cupcake. One run build production. Okay. One run build production, which is this command. Cool. Distribution here, assets. Oh, we don't see localhost. Yes, the backend URL is correct. SHA backend walrus.codes. SHA backend walrus.codes. But then why are we not getting it in the image? Let's build this. Docker build target Nginx production version, and yes, from here, and some tag would be Nginx, and here shit, Docker is not running. Docker has to run for this to work. Shit, but I am the perpetuator of codes. Shit, build size is large. Wait, build size is large for the build size is large, so the AWS machine is not getting the new image. When I did saw an error there in this pull and run. This failed to copy, failed to send right to this thing, no space left. This the thing. And then okay, this was the error for the backend. Then we copied Nginx. Nginx, I guess, it started working. Nginx production. Then we did the same thing for TUI, but TUI is not working, I guess, also because no space left, because TUI is has some high size. Sorry. Hello, how's your project going on? It is deployed, at least, and now we have to fix some bugs. And the bug is, if you go ssh walrus.boards and just press enter, you get this UI. But the problem is, if you select a type of game, it does not connect, which is something we have to fix. The size, can we see the size of image? Latest. For TUI, the size is 1 GB. Compress, no, 115 MB for AMD 64. Okay, and what is the size for backend? Latest Linux image 113 MB. I guess we have to change the size of these things. AP South. This is the instance which is running. How can we see storage? Yes. Storage encrypted? No. Delete on termination? Yes. Volume 8 GB. Volume size there is 8 GB. Let's see. I dot ssh. We are going to ssh into the machine AWS. This is the key, and the place where we want to ssh is walrus dot codes, and the port is 4321. Shit. User and shit. Yes, we have to give in the user. Ssh I key is dot ssh AWS user name Ubuntu @walrus.codes, which is the IP address, and the port into which we want to ssh is 4321. Yep, we are here, and sudo I docker image ls. We have 3 images running. Docker yes processes. Okay, all of them are running. We can ssh. Yes, we should ssh and not ssh. Docker exec. Go into a terminal. Go into one of these containers which are running. Exec it. Let's go into Nginx production. Nginx production and sh. Failed to create console. No space left on device. No space left. df h human readable. Okay, available is 0. Root has this much, and 6.7 GB is used. Okay, why is Docker taking this much space? Docker system df images and build cap. Wait, images are taking 4 GB of space, and the whole operating system and everything else is also in the 4 GB, I guess. You're currently working on core backend. What about your UI later? Core backend is fine. Core backend is fine. Yes, project is live. I am just fixing some bugs in the production. That is, if I run this locally, then using Docker Compose, then the TUI is able to connect to the backend, but the TUI is not able to connect here in the production. Shit. Yes, there are some bugs. There are some bugs which I have to fix. I follow your GH to find out more. Wait, GitHub. Maybe contribute. That would be cool. You would give me a hand. Docker image size is too much for simple app. Seems like you are correct. So we need to give more space to this, and when we need more space for our AWS instance, elastic block storage. Yes, we have to create a elastic block storage and attach it to our AWS instance. But yep, we have one, this one, and this one is attached. This one is attached to our instance, and this was done by Terraform. Instance. Here we just have to attach a new bucket, and cool. we can say Terraform AWS provider, and we can see how to give information about the bucket when we are creating an instance on AWS using Terraform. Cloud compute, AWS instance, EBS block, elastic block storage, EBS. We have to specify applied only to specific EBS block devices volume when you configure them. Okay, these conflict with volume tags. Okay. EBS block device optional. Okay, we just have to, I guess, create a EBS block device. And then give information here for which we can go here and describe a new output and say block device is the name without any spaces. Value is going to be AWS instance dot walrus dot root block device. There is nothing. Root EBS, if that is a thing. Okay, Terraform output. With that, we did not see that thing. Description is block Terraform output. Okay, we do not see this. I guess we have to apply Terraform apply. Block device is empty. Okay. Yep, block device is empty. So if block device is empty, how do we have this block attached to the instance? How do we give AWS block storage to instance using Terraform? That would be it. AWS EBS volume. Get the instance type, everything. Create the EBS volume and then attach them. AWS volume attach. Create AWS EBS volume. Name would be example volume. The place, size, type. Okay, that is pretty cool. Makes sense. And then attach these two together. Cool. So AWS EBS volume. Here it is a resource, and to define this, we define it volume dot tf Terraform resource AWS EBS volume. Name would be main storage volume.tf, and this takes in availability zone. AP South size 20 GB. What is the cost of these things? Instance, life cycle manager, and there are also types of these volumes. If we click on create volume, size, IPO, IOP is the request number of input output operations per second. Okay, 3000. Throughput, speed, availability zone, snapshot. Again, there is no type. There is a type, volume type. What are these? General purpose, provisioned, magnetic, HDD, HDD. And what is the difference between these two? General purpose GP2 and GP3. Difference between these things. In GP3, GP3 volume offers 20% lower storage costs compared to GP2. Okay, so GP3 is cheaper. Okay, that is cool. We'll use GP3, I guess. Type is GP availability zone, and 20 GB, I guess, should be enough. And then instance.tf, here we just have, no, we don't have to do anything. We do have to do something here. Inside instance, we have to attach resource, attach attach instance. Using this AWS volume attach. Attach main storage, this would be the name. Okay, and then I guess it takes instance ID. AWS volume attach does not exist. AWS volume attachment exists. AWS volume attachment, and here we give volume ID and instance ID and device name. Device name is where the device is. Device name required the device name to expose to the instance. For example, this okay, where, okay, volume attachment, okay, that will attach this to SDA1. Okay, cool. Then Terraform plan, this will tell us what Terraform is going to do next. Hello. Yep, I mean, like, what else is there to so this is going to create a volume where right now we know the availability zone, final snapshot false, size is 20, this, and there was another tag which we could give here, which says that if the instance is like goes off, then delete this volume. AWS instance, AWS volume, EBS volume, AWS EBS volume, this one. There are options: encrypted, false if true, the disk will be encrypted, final snapshot if true, snapshot will be created before volume deletion, no. Size, we have given size. Type, okay, cool, that is fine. Let's just create this. Terraform, apply. Cool, this will create a new volume and attach that volume to our instance which is already running, which will give us more space because we need more space when running Docker. Hello, Saif AL Gym, crazy name, and wrenched. Your website was cool, is cool. Anyway, and you work in Microsoft. EBS volume this to this is already in use because there is something already running there. So I guess if we either we could delete the instance and create a new one, or there might be some way to change the volume. Change AWS volume. Yes, change AWS volume on our running instance. Use modify volume feature. We want to use Terraform. Change AWS on a running instance. Terraform depends on whether you are modifying a root. We are modifying the root volume. Defines the storage independently, and this links the storage to the instance, modifying additional data volumes. If your volume is defined as a standalone EBS volume attached via this thing, you can change its size or type using this. Yes, we have done it. Update Terraform EBS volume resource, increase the size, apply changes, Terraform apply Vercel, modifying the root volume. Yes, that is what we want. Expansion, configuration, workaround. Expansion, you can often increase the size of volume via Terraform without recreation, provides the instance supports it. Okay, Terraform will update the volume's attributes. If the root volume is defined inside the instance resource under some root block device, it is not defined like that. Import constraints, workarounds. If you need to avoid instance, I guess we will have to do instance recreation. Terraform destroy. Destroy. This will destroy everything, but it will ask us. Yep, if we enter yes, it will work. And right now, walrus.codes is working. This is the website. Okay, thank you. I will keep streaming. If we delete this, and the instance is going down. Yep, it is loading now. Yep, instance is deleting. Cool. And why are we doing all of this? We are doing all of this because Docker is taking a lot of storage to download the containers. So we have to add manual storage, and for creating the instance and doing anything with the instance, we are using Terraform. And since right now the whole Terraform code is separate from the whole this backend, but what generally happens is people put their Terraform code also in their main repository inside a different directory. Like here we have this infra directory which has the Nginx code. They also create another directory here, Terraform, and they add their Terraform code here. Yes, that is what we will do too. Let's copy from documents, Terraform, documents, programming, Terraform, everything from there to /infra Terraform. Okay, go to infra Terraform ls. We have all this. Are there some crazy things that we would not like to commit instance.sh, initial.sh. Nope. Everything here is cool, nothing crazy. This just downloads our stuff for us. Instance.tf. Nope. Yes, we have to do Terraform init to install, to set everything up like git init. Okay, everything was destroyed and we will build from here. This is Terraform inside our main backend, and now if we refresh, we are not able to refresh, which is cool. Here, code. Inside infra, we have created another directory which has the Terraform code. Okay, Terraform initialized. And but before making a commit, we would like to see is there some crazy stuff that we would not like to be shown. This is common, like anyone can know this. There is no problem with this. Our AWS tags and stuff. Keys. This is a public key, so totally fine. So totally fine. We can have our public key here, no problem. Main.tf. This is also totally fine. Anyone can see this. Network. This is also totally fine. This is just creating a VPC, creating a subnet inside that VPC by taking the VPC ID, a gateway to connect to the internet, route table, security group, which we add to our instance later on, and we are defining rules on that security group. This one opens up port 22 to connection from anywhere. Port 80, we are opening port 443 for HTTPS connection, port 4321 for SSH connection, and this is egress. Egress is who can access this. Let me actually see what these two different things mean. Ingress between and egress and AWS security group, and we can even use examples. Cool. This we have two things, egress and ingress. Egress, ingress, incoming traffic to your resource. Egress, outgoing traffic from your resource. Okay, makes sense. So when we are defining here ingress, anyone from this port, which means this CIDR block says that gives us an IP limit from which anyone can make a TCP connection in this port range, which is a single port, and this CIDR block means any IP address. This thing after the slash means how many bits in this IP address given on the left are fixed, and 0 means no bits are fixed. Therefore, these can be anything, which includes any IP address on the internet. And when we are defining this egress, protocol -1 means any protocol to anywhere in this security group. Ooh. Outputs fine. Anyone can see this output. Yes. Providers, anyone can see the region. Cool. Terraform FC3. I guess this might be problematic. This backup thing, and variable store ef, that is fine. AWS region is one variable, instance type is another, and a did and volumes, that is totally fine. I guess everything is fine except these two folders and these two folders. And also Terraform needs our AWS credentials. Okay, how to give inline, how to credentials inline in Terraform. There are provider. Okay, can we not give this while we are running a command? I guess we cannot. Access key and secret key. We can store these things as GitHub secrets, but how are we going to insert them inside a file? Lord, yep. I have my AWS secret key and access key as GitHub secret, AWS secret key and access key as GitHub secret. Can I just use in secrets dot access key in Terraform provider config, and will I get the access key? Yes, but with a small caveat. Your reference GitHub secrets in YAML workflow, but not directly in .tf files. Here is how it works. Okay, how do you do this? In your GitHub actions, all the YAML, you pass the secret as environment variable k, and then run Terraform apply. Okay, cool. We can pass these things as environment variables, and inside no credentials are needed. Okay, so Terraform takes AWS credentials from env. In case it does. Yes, Terraform can automatically take credentials from AWS EMD. Okay. For this, what do we have to do? Instance AMI. No, it is called IAM. We have to create a new user, IAM. IAM is a way to define a new user who has access to some security thing. Deactivate or delete access keys for user. Okay, for the root user. Canonical, this is the root user, and this is access key for the root user. You can look at this, but you don't know the password, so pretty easy. And I guess I can just delete this. On this, delete. Cool. Enter the access key in the text field, and to confirm the deletion, enter access key in the text field, which is AKIA, or you can just select copy. Delete. Cool. Access key is deleted. Pretty cool. Now we have to create a new user. I created one user by the name Terraform. We will just get access key for this. There is a access key. We need an access key. These are the like privileges that this user has. Security credentials, access key, yep. Actions, deactivate, activate. This is the access key. And how do we see the secret key for this? We can put the access key here. Slow. We can put the access key here. And the name by which Terraform reads them is Terraform AWS keys from env, AWS credentials from env. What are the two things that it needs? AWS access key ID, AWS secret access key. AWS access key ID is, what is the problem? This is the key, and AWS access key ID. Cool. Add secret. Secret was added, and we also need to add AWS secret key, AWS secret access key. AWS secret access key. Here comes the secret access key. How do we get the secret access key for this? Actions, deactivate, edit description. For Terraform, that is fine. Get access key AWS for already created user, IAM. It is impossible to retrieve a secret key for an already existing user. Okay, so we don't have to go there. The access key is like right here in this credentials folder, but I do not want to show it, so I will hide my screen and I will just put the access key in GitHub secrets pool. You cannot see, hopefully. Copy and just GitHub enter. Cool. The access key is there now, believe me. Okay, so we have added the AWS access key, key ID and AWS access key. Why do we need this? We need this so that Terraform can access these. And why do we need to give access to these things to Terraform? We are using Terraform. This talks to the AWS server. So that is like very small. This Terraform talks to the AWS server, and for this talking, credentials are needed. Which we have put forward in our GitHub secret. They are there inside GitHub secrets, and cool. So Terraform can use them. And why do we need Terraform? Here in our CD pipeline, we need Terraform in our CD pipeline so that we can get the latest IP of the instance on which our server is deployed. IP, latest IP, for which we need Terraform. Cool. So now access keys. We just have to update the workflow here. Here, when we are push here in this job, pull and run, we need to know where we are going. Here with host, the host is the only thing that we need Terraform for. So pull and run. Here we have said that this thing needs push images. Deploy cd tf.yaml. Do all this. Name is this. Using property jobs on this. Property jobs is not okay now because jobs goes to left hook. And this thing only runs after images have been pushed. Okay, so after the images have been pushed, we need Terraform to get the latest IP and then use it here. Okay, so we will define a new job here, Terraform job, and no, I guess using the same computer would be, yes, we need to use do this as a single job so that name. Okay, this only happens after checkout. If there are any changes in Terraform configuration, then this would run. Terraform changes. And this does not use anything. HashiCorp has its own Terraform action, which is pretty cool. GitHub actions, okay, prerequisites, GitHub account, HCP, HashiCorp, and AWS account. These two are the secrets that we need to put forward. Yes. And then on pull request, environment variables. Yes, we do env here. Yep, env. We need to put AWS secret key, AWS secret key, and AWS access key. But I guess the names are not these specifically. The names are AWS access key ID, AWS secret access key. Wait. Hello, DomDMK. AWS secret access key, AWS access key ID, secret access key access key ID that should work. This will put the AWS access key and the key ID as environment variables, and then they would be used or picked up by Terraform. Scripts, same scope, run the command that we give here. Terraform init, yes, first of all, Terraform init, then Terraform apply, I guess, auto approve, whatever the change is, push it, Terraform output in raw instance IP, what is the name by which we have defined Terraform output. This is the name, public IP. A lot of files are here. Cool. Terraform public IP output raw public IP. Okay, but what do we want to do with this public IP? We can say export, yes, backend URL, export backend URL equals this Terraform public IP, but not just this. You have to say yes, like this. Run this command, whatever is the output of this command, put it as the backend URL, and then here SSH host, no, not backend URL, SSH host equals this, and here just give SSH host. I guess that should work. Okay, three things are happening. One is image is being built and being pushed to GitHub, and then we are using Terraform to start our AWS instance, all from CI/CD. Start our Terraform instance, our AWS instance using Terraform. If the instance does not exist, then a new instance would be created, and if the instance does exist, then we would just take its new public IP. Cool. And then we put that public IP as an environment variable, and then it should be accessible here with this SSH host. Let's see. Okay, you can sleep or maybe drink coffee. cd.yaml from here. Cool, we don't have to do anything in this file. tf, no, this is not about tf. This file can be renamed to, this is actual cd.yaml. The other one is more like, I guess, images.yaml. This would be cd.yaml and another tf.yaml. Terraform.yaml on pull request to branches main and how to run job in GitHub workflow when change made in a directory. When change is made in the Terraform directory, then this does BlackRock, and no, BlackRock does not own my channel. BlackRock is a finance company, largest asset manager. Shit, no, they do not own my channel. Go on push to this. It on push path. Apart from branch, we can give path. Okay, makes sense. You have to give in path. Paths whenever a change is made to infra/Terraform anything. Okay, and jobs that we need to run are jobs. And job number 1 would be Terraform. Name Terraform runs on this, and then steps is step number 1. Name for step number 1 is checkout. Yes, we need to check out, get the latest code on this new machine, and also we would like to set up environment variables. One AWS access key and AWS key ID. Okay, and just this, like very similar to this. Name Terraform changes, change Terraform, do Terraform init, and then Terraform auto approve and apply. Cool. That is pretty cool. Images should be cool. This should be cool. And now we have to change. What do we have to change? Yes, in infra Terraform dot git ignore file, which will ignore dot Terraform and dot Terraform dot Terraform ls infra Terraform dot Terraform ls a infra Terraform dot Terraform. Yes, that is another thing. Dot Terraform dot log dot HCL, and then Terraform F state and Terraform F state backup. Okay, that should work. We have the Terraform code, but shit, no, we do not have the Terraform code. We have to SSH into the right directory and then do Terraform. Here, before, not here, here. Name cd and run. This runs a command which is cd go to infra or dot slash infra slash Terraform and then run these commands. Cool. In cd, before running the Terraform commands, cool, go to the right folder, and this should work. In theory, this should work. Wait, what? I know. They own your shit. I'm caught. I'm caught. In theory, this should work. Changes are made to these files. Cool, cool. Fix cd. Okay, get push origin main. Okay, a lot of things are going to happen if this works correctly. That is, if this works correctly, if this works correctly. First of all, the push images is the only job that is running. Why? Workflows, push images. This is the only job that is running. CD is not deploy the latest version. Deploy the latest version. Yes. This is not running. Whenever there is a push on the main branch, this should run. But this is not running. Images is running, but CD is not running. Deploy the latest version. This would work. Like, there is no problem with this. But oh shit, this is the other one. Why invalid workflow file? Invalid workflow file. Why? Line 9. Run and pull. The workflow must contain at least one job without dependency. Column 3, line 9. Pull and run. The workflow must contain at least one job without dependency. With no dependency. This is the CD workflow, and this depends. This does depend on this. So we can put them in the same file. We can put them in the same file. I guess we'll just put them in the same file. To run this one depends on push images. Cool, this should work. Okay. GitHub workflows images. The new name for images should be cd cd.yaml, and the other one got lost. Cool. Cool. And everything git commit fix cd git push origin main. Cool. Actions. There is a single job running push images, and after that pull and run will run. This will take some time to run because we have to push the latest images. This is still infrastructure code and we haven't begin to debug the application. No, we needed to do this because we wanted Terraform to increase the space on our AWS instance. And yep, whenever we make some change in our Terraform config, this would happen. Cool. Pull and run. Push images, building images. We are on the TUI image. We are on the Go, yes, TUI image. Okay, this takes a bit of time somehow to build and run. Okay, cool. Exporting layers, it is built. Pushing layers. Seven seconds done. Okay, cool. This job ran completely, and now this will run. Pull and run, which will take the IP of the machine or the instance on which this is running. But right now, if you go to AWS, AP South, refresh. Yep, there is no instance running. This is also terminated. So this is also terminated. Wait, why is it thinking so much? Okay, wait. There was an error on pull and run. Okay, on the next job, Terraform changes. There was an error because Terraform command not found. Okay, Terraform on GitHub. Ubuntu latest machine, and we can also use GitHub Actions for this. But yes, this thing also suggests using GitHub Actions. Manual installation. Yep. Okay, shit. I guess we will use GitHub Actions. We don't want to do this. Okay, we do this, which installs Terraform, and then we can use Terraform commands. Okay. Apply, auto approve if, push. Okay, we use this GitHub action to install Terraform. Make sense? Before, yep, and we have to do this in both the places. Okay, shit. Name setup Terraform uses this action with Terraform version this. Option default is to latest. Okay, let's not give this. Just 2 lines of code to install Terraform before running Terraform. Setup Terraform. Now we will get the Terraform command. Push origin main. Hello, way to access your website. It is like deploying again. I destroyed the instance, and the instance is going to be set up again in a minute, maybe 2 minutes. And it goes for operating system. For operating system, there is a dinosaur book. Dinosaur book. Yes. This you can read this dinosaur book about operating systems. And what else there about operating system? Yeah, dinosaur book. Yes, if you want like deep dive, and I don't know how to get a smaller, simpler dive because I haven't done anything much with the operating systems. This would be it. Yep. Or maybe test out your Linux skills. That would help. There is no instance running at this instant. Okay, when these images are pushed, then this pull and run will run this job, which will do a couple of things. This will set the environment variables for AWS keys, AWS credentials, because Terraform needs them to do anything. Then we will run Terraform init to initialize a Terraform directory, then Terraform apply if there are any changes in Terraform, and then this output raw public IP. This command Terraform output raw public IP, this will give us the IP address of the instance which was just created, and make it equal to SSH host. And then when we are SSHing into the target machine, the instance, we are using SSH host here for the host. And this is still pushing images, which is done. And shit, we got error again in this Terraform changes. Why no configuration files? Terraform initialized in an empty. Are we not doing CD? We did do CD into this. I guess this has to be in the same thing. CD infra Terraform. Okay, and now shit, this will again run this whole thing. Wait, I guess we can change this so that we are not building a Docker image every time. We can change this configuration. Scripts. Wait, not scripts. Here, cd YAML. We can say that whenever there is a change in the apps folder or in the commons folder or in the main package.json, only then make the new Docker image. But then we do not want the same configuration for this Terraform command. And if you want different configuration for this other job, then we have to define them in different files. And if we define them in different files, we would get the same error we were getting a minute ago in actions. I guess it was this one. Yep, the workflow must contain at least one job with no dependencies, which should not be the case if we do spread the code. Cool. Docker login, pushing the images. Cool, images were pushed, and it finally this thing is running. Pull and run. Terraform changes. Okay. Terraform is initializing. Terraform apply. This will initialize AWS instance. Right now there is nothing here. Terminated. There was an instance which was terminated. Terraform is creating a new one. 15 things to add. It will add security group, everything. Cool. Creating volume. Okay, and we will see that this here, this is pretty cool. I had books. Wait, okay, you had books. Okay, this a new instance has started running, but we got error. You want something other than book? I guess operating system AKTU notes. You can read these AKTU notes if you want. Like, they might be helpful, but there must be like some playlist on YouTube. I also want to see. operating system full course. Explain who is a like full operating system person who makes operating system, because operating system is very complex. No one makes a operating system except Linus Torvalds. And yeah, wait, we got an error in GitHub. Okay, this thing failed. Why did this fail? What is the specific error that we got? Error was this: attaching EBS volume to EC2 instance, initial invalid. This for Unix device attachment point. This is already in use. Bad request. Okay, so we cannot attach the thing there. Okay, because when the instance was created, dev SDA1 was already being used. Okay. I want to create an AWS elastic bucket container, I guess EBC block container, elastic block container, and use it as the root container for my instance in AWS. For my instance in AWS, using Terraform. EBS, my bad. Elastic block store. Okay, get the AWS instance root block device. Okay, shit, we have to give this root block device. What? Oh shit, we don't even have to do anything extra. Or using separate volume, EBS volume plus EBS volume attach here and attach this to SD1 root device name for Linux. But the problem with this second approach is that there is a problem with this second approach, that the problem is once the instance and the bucket are not a bucket but block storage are created separately, and the instance has its own default root block defined, and when using dev sd1, when using /dev sd1 as the attach or mount location, it gives error since the default storage is already attached there. And shit, we will go forward with this, but Claude did suggest this thing which gives error. So let's see what does Claude think about this. Right, the issue is that when you launch an EC2 instance with an EMI, AWS automatically attaches a root EBS, elastic block storage volume at this. So trying to attach another volume there gives conflict. Second approach with this attachment is really only suited for secondary. Yep, that's the thing. And this is only suited for secondary things. Block root block device. Okay, now we are going to make some changes to our Terraform instance file initial.sh. No file exists as initial.sh. Initial.sh is like right here, instances. It is just hallucinating. Root block device equals, we have to give some things, volume type gp3 cool, and these are the same things we gave here. Availability zone, yep, we would also like to give an availability zone. AP south, A1 cool, we can delete a volume being created. In instances, we don't need to attach any volume. What is the change we made here? Def, what are the changes? We added the root volume when creating the instance. Cool, and delete. Push origin main, pretty cool. Okay, that should work, and this will not trigger. Well, this will trigger the whole action of also. This should have also triggered this Terraform action paths if there is any change in these files, and there was a change in these files. So why is this not running? Name is Terraform. Is it because there is no name for this? All reports does not work. Cool. But the thing is, you would have to get the latest. We are able to get the latest IP and deploy the code there. But how do we point a domain to the latest IP? How do we communicate to name.com? Name.com. This is the place where I have the domain. And it is, I would not like to manually go here every time that a new instance is created and click on manage DNS record and change all these DNSs. What would be cool is something else, something automatic. How to change DNS record automatically on name.com. Maybe there might be something on name.com. Support API. Shit, bro, people have their API. Get started API, dashboard API. That is what we need. Manage your integration. Core API, getting started. Core API. Okay. Yep, API. They have their API. You can make a request. DNS script, update a record to your current IP. No. Run this script on a cron job. No. Using Terraform. Yes, we want to use Terraform. Terraform. This. Terraform has a provider. Lex Friedman, Lexio, name.com. Terraform name.com provider, Terraform provider for name.com providers, provider name.com token, this domain name, change this cname record, answer this, and point this to something like this, or point this to something like this, answer. Many records per domain example. Okay, we can just do this. API docs. Is this like legit? 1 star. Maybe this is not legit. Maybe they might take all of our credentials and shit. This thing failed. Terraform changes failed. Why? Root block is not expect. Did you mean to root block device? And ROOTBLOCK block DEVICE. Root block device is not expected here. Did you mean to define a block of type root? What is the difference between these two, this and this? Root block BLOCK device DEVICE. Root block device DEVICE. Root block device. We can go to the documentation, AWS or Terraform, AWS provider, AWS instance, root block device. Okay, delete on term. Okay, these are the options that we can give to root block device. So why is this not working? Let's try to run this locally. Terraform plan, Terraform plan, give us the plan, root block device. Did you mean to define a block of type root block device? Yes, we did. Root block device. Delete on termination is one option. Encrypted is another option. But ROOT root block device supports the following. Option. Everything is optional. Literally everything is optional. Terraform init maybe. Terraform AWS instance root block device. Yes, how do you define root block device? That is how we define root block device and all the things inside that device. It can also take tags, and all of these are optional. Volume size, root block device equals this. Keep this out one. Instance emi id defines the place AP South. Terraform plan. Error. An argument type root block device is not expected here. Did you mean to define a block of type root block device? How is this error? Root block device error 4 years ago. Encryption error failing. Not expect. Yes. Yes. Root block device solution. Oh, we just remove this availability zone. An argument is not expected here. Availability zone. Okay, shit. Okay. We do not use equal to in this when we are defining this. Okay. And what are the other options that we can define here? Root block device. Delete on termination. We can make it equal to true. Delete on termination equals true. And also encrypted. No. Some tags. Let's say tags equals name is going to be main. Terraform plan, and there shouldn't be any problem with this. Seems like so. Okay, cool. Now, two things. One is this should not fail this time, and second is that why did our what is still running? Why did our other job not work? We have two jobs here. One is this Terraform, which checks if there is a pull request on main branch in these files, then do the job. But they did not run. What's that? This workflow didn't run when a change was made in the infra/Terraform directory. And there might be a typo. TERRAFORM. Infra TERRAFORM. No typo. Cool. CD. There are two bugs. Okay, there are two bugs. CD. Yes, first of all, yeah, that CD is like no. CD should not run like that. Working directory. Okay, instead of CD, the more professional thing is working directory. Where did you host it? On AWS. This is being hosted on AWS using Terraform. And this. Where do we get working directory? Runs on this. After checkout, I guess. Applies to all steps. Okay. And bug 2, checkout 6 doesn't exist. The latest version is v4. And what do we have here? Shit. I guess v6 does exist. Checkout. Shit, yep. 6 is there, so Cloud has not caught up. We'll use v6. Defaults, run, working directory is /infra Terraform. Cool. Yep, this should work. This should work. Only in it added plan you would like to want this as well. Why would I like to have plan here and not apply? Like to have plan here when I am already using apply to make the real changes. Yo. Fair point. If you are running apply directly, then plan is redundant since apply. Okay. However, the common reason to have both in a PR workflow is plan on the PR. So reviewers, okay, have plan on the PR, but when we are merging, then push this to main. Okay. Like actually apply the change, but I don't think we even need this job, because whenever we do make an actual change, our CI/CD pipeline should run, because we need to pull on the new instance and start the server there on the new instance. Status, git add all of this, git commit, git push origin main, that should do something. Also a name, we'll look into this name.com API thing. Okay, this is running, and also there is this problem that we have made a lot of commits with the same name, fix CI/CD. What we can do is we can squash all of these commits, and yeah, they would be seen as a single commit then. Image is being built. Is there something running? There is something running. Phone is going to die. It was supposed to be charging. Building. Okay, it is on the TY. Push and build and push, go TY. Okay, done. And now pull and run is running. Okay, we have Terraform installed. Terraform changes. Terraform has been initialized. Okay, this is suggesting the plan. Okay, this is actually making the thing. And we got error. Why? AWS keep makes sense. Wait, what? AWS key pair ID is this. AWS key already exists. If it already exists. Okay, the problem is in it. Terraform does not know. Yes, Terraform does not know, has no idea that some servers are already running, so do not run them again. Terraform init is giving us problem. Hello, who is it? Hello, yeah. How is it going? Okay, okay. When we do Terraform init, then Terraform reads our whole configuration about the instance that we want to launch and then makes a plan whenever we make some changes to our configuration. Terraform looks at these files .terraform and .terraform log.html to see which things have been changed, and then Terraform makes a plan. Like if a key pair already exists and we have not changed that, then Terraform will not create a new key pair. But since here we are doing Terraform init always, then Terraform thinks that we are initializing all of this for the first time, and therefore Terraform will try to recreate things which already exist, and that is why we are getting errors. So the question would be, is it safe to push onto GitHub the Terraform the files created by Terraform init, since if I don't, then Terraform thinks that all the that the config is being applied for the first time and tries to recreate things which already exist, and this leads to a conflict. The issue is you are describing a state file, not the files created by state file. What this creates is .terraform directory. This contains provider binaries, modules, and cache. You should not commit this. Okay, what is inside .gitignore by default is generated by Terraform init every time. It is not tracks existing. Okay, what tracks is EF state Terraform. Okay, which is the real issue. The state file is what tells Terraform here these resources already exist. Without it, Terraform thinks everything needs to be created from scratch. You should never commit this to Git either. Okay, shit. Okay, what to do then? The correct solution is remote state backend. Store the state in S3, standard practice for AWS. Create this bucket key region, create the bucket and store the state file there, and then create the bucket and dynamo db table once manually or write with a separate Terraform config. Okay, create the bucket, whatever dynamo db is, and Terraform init picks up automatically from the config. Prevents concurrent applies. Your git ignore should contain all of these, and this is what we are putting on git ignore. Right. I guess I should lock in. You should lock in. Do you know the maths of? Yes, he is pretty good. And by login, I mean mod. Your लोग लोग मजे लेके आ रहे आप oh shit, okay, he is doing something I guess in the server. We need this state file to be available. Okay, Terraform with GitHub workflow, HashiCorp. GitHub workflow with AWS. Deploying Terraform using GitHub Actions, automate Microsoft. Wait, okay, S3 bucket. First of all, why can't I push the state file? Why can I not push the state file? The main reason is that the state file can contain sensitive data in plain text. For example, if you create a RDS database, the state file stores the password. Okay, but we do not create an RDS database, but okay. Okay, second reason, concurrent access corrupt. No logging mechanism. If two people or two CI runs do a Terraform apply at the same time, both read the same state, both make changes and then overwrite the others, raise conditions. The third reason, state can get out of sync easily if two people are not working, but okay, makes sense. Okay. First of all, okay, we need to create a bucket, which is Amazon's way of storing data, and store the Terraform state file there. And then this is a one-time thing. And then every time a commit is made, whenever we are running Terraform commands, then from the bucket, we will get the state file, make the changes to the state file, push the state file. Cool. So first step is create a bucket and put the state file there. S3 bucket and put the state file there using Terraform. There's a chicken and egg problem here. You cannot use Terraform to create like some other instance of Terraform, not this one. Create the S3 bucket without a backend, local state provider AWS bucket, and then AWS bucket versioning enabled Terraform state resource AWS S3 bucket server side encryption configuration. This bucket algorithm AES RSA apply server side encryption by default, and then block all public access to the bucket. Okay, and then resource AWS DynamoDB table, your project Terraform lock. Run this once, cd bootstrap initial, and then apply, and then configure the main infrastructure. what are these commands? First, we are getting the provider, cool, and then AWS S3 bucket. This is creating the bucket, but what does this bucket mean? And what is a bucket? See, is AWS bucket like Elastic Block, EBS, block storage, which is like hard drive? No, they are quite different. They are Here is simple mental model. S3 simple storage device, object storage. Think of it like Google Drive or Dropbox. You upload files and retrieve them. Okay. And store files, objects, JSON, backup, all that stuff. Cool. Access via HTTP calls. No file system, no folder, nothing. We just key value pair. This is like a key value pair where the value can be anything. Virtually unlimited storage, cheap and highly durable. That is pretty cool. This thing limited, more expensive than S3. Okay, so we can, I guess, use S3 for like local. If you want to store your wedding images, you can use AWS S3 bucket. Okay. Bucket is like remote key value pair where the value can be of a lot of different types, where the value can be of a lot of different types. Pretty cool. Exactly. Okay, cool. Pretty cool. Let's like play around with AWS bucket for a little bit. Where do we get buckets? It's not in here. Inside instance S3 bucket. So S3 bucket, we will create a bucket and let's upload onto the bucket something big. A movie. It would be cool to upload a movie there. Let's first of all create the bucket. General purpose, yes. Global namespace. By default, S3 creates general purpose buckets in the global namespace. Bucket name, walrus bucket. Choose bucket. Copy settings. No, this is cool. Ownership recommended ACL. All objects in this bucket are owned by this account. Access to this bucket and its objects is specified using only policies. Okay, objects in the bucket can be owned by AWS accounts. No, this one is fine. Ownership, block all access. Public access is granted to buckets and objects through control lists. ACL, access control lists. Block public access to bucket and objects. Remove this. Turning off block access might result in this bucket and the objects within it becoming public. It is fine. This is for testing. AWS recommends that you turn on block all public access unless public access is required. Nope. Versioning disabled. I guess that should be cool. Add a tag. Walrus bucket. Default encryption, no encryption enabled. Bucket key. Using S3 bucket key for this thing reduces the encryption cost. Okay, and server-side encryption on AWS. Okay, cool. Yes, that should be enough to create a bucket. Shit, the bucket name contains that aren't allowed. Bucket with this already exists. Okay. Walrus bucket P, as in like personal. I acknowledge. I do acknowledge. That will do something. Okay, we have a bucket. Yes, we do have a bucket. And this is publicly accessible. I will add something to this and then you will be able to access the bucket. Let me... I have a song which I can upload. Find my name. How do I upload from add files? Cool. Not this. Gintama. Music. I'm deranged. This one. Cool. On the nature of day and light. Destination is this bucket. Okay. Uploading. Shit, this might cause problem in OBS, and this does cause problem. Okay, my bad. That took all the upload bandwidth to upload the bucket, but now it is fine. Okay, now it is fine. And the thing has been uploaded. Summary is destination is this. Owner object URL. Anyone can go to this. This file does not seem to have XML. Access denied. Okay, why access denied? How do we change the access so that anyone can access this? Edit. Permissions. Okay, makes sense. Public group can read. Oh shit. Edit. Shit. Why can't this bucket has use ACL grant access. This bucket has the bucket owner enforced settings for object ownership. When bucket ownership enforced is applied, use bucket policies to control access. Okay, this is the thing. And all objects in this bucket are owned by this account. Okay, ACLS. Okay, bucket owner referred if new object has been written to this bucket. Okay, let's see. If we refresh, we do not see. We do see edit. Okay, anyone can read. Ooh, I do understand. And authenticated users for the group can also read, and anyone can also read. Cool. Save changes. Cool. Object URL is this, and let's go. Okay, and now you can see this, the song, and hopefully that didn't give me copyright. And this is a cool song. Let me upload one more to this. Okay, what do we have to do? AP South, go to AWS, search for S3 bucket. This is the bucket we just created, and here objects, upload a new object, add file, this one, the last dinner party. And shit, when I do upload this, the stream will go down. Yep, the stream will go down because all the upload bandwidth will be used by this. Cool. And we are back up. Cool. We are back up. Cool. It is working again. Cool. And this is the one last dinner party, and we can change permissions for this. Read globally. Anyone can read. Red does not always mean bad. And properties, go there. Wait, that is not the one. Wait, no. On the nature of green light. No. This one. Rifle. We have to change the permissions S3 here. Bucket permissions. This is the bucket, the permission for this object. Permissions, edit, read. Anyone can read. Cool. And we click here. Yes. Okay. Here's the last party copyrighted, because of course it is copyrighted. If I play this, I will not be able to earn money by this stream, so you can just listen to this here. Cool. So we know, because of this bucket, things about bucket, information about the bucket, or what is AWS S3 bucket. Now we need to create a bucket and upload our Terraform state there, and then get it every time, then delete it every time whenever we are doing something with Terraform. That would be it. And before we do that, I would like to go to the washroom, and I will be right back in a minute. I'm back. Pretty cool. Okay, now we can either create the bucket through this AWS interface, or like pro programmers, we will create the bucket using Terraform. Resource, AWS S3 bucket, Terraform, and bucket, your project. Okay, what is this bucket? Or Terraform, AWS provider. S3. S3 bucket. Bucket, what is this? Bucket property. Tags, environment, dev. Bucket optional forces a new resource. Name of the bucket. If omitted, Terraform will assign a random unique name for the bucket. Okay, I guess we should not, in that case, give this thing a name. My TF bucket, my TF test bucket. And main.tf provider AWS availability region is AP South. Terraform init, download the provider which already was there. Okay, after creating the provider, we define the bucket with that provider. Bucket.tf resource AWS S3 bucket. Terraform state is the name. Bucket Terraform state env variable.env. Instead of this env variable, but var.env does not exist. var.env does not exist, so variables.tf to create a variable. Variable name of the variable would be env, and here we have to give value. Value is dev. Value not expected here. Why? Terraform variables. Variable name, type, and description. Shade main.tf Terraform version. Give latest version of this thing. Require provider version for this, and version Terraform init shit variables string Terraform 11 and earlier require type constraint to be given in quotes, but it is depreciated now, so substitute commas with emptiness. Type value or default table. Yeah, default is not the value that we want to give because it is like very common. Walrus here. Google versioning enabled. Okay, server side encryption in the bucket. Okay, so we have created a bucket, right? Versioning, either we give it like this, encryption, or we can give it right here, which we have done. Server side encryption configuration, server side encryption configuration. Okay, these names are pretty cool. Apply server side encryption by default. AES 256 is the encryption algorithm. Block all public access to the bucket. AWS S3 bucket public access block. For Terraform state, bucket ID is this. AWS S3 bucket policy, I guess. Public access. Terraform state bucket equals AWS S3 bucket Terraform state dot ID and block public ACLs. It and like also the people who are here, you can go to these websites or these links. They have songs uploaded on our AWS bucket. S3. The name of the bucket is this, Walrus P, and these are the two songs. Block public ACLs. Block public policy, true. Ignore public ACLs. Restrict public buckets, true. What is public ACL? It is public ACL and shade public access control list. Okay, public access control list is a specific permission setting that grants access to your bucket or its individual objects to everyone on the internet, and we are saying block public ACLs equal to true. Okay, makes sense. Block public ACLs equals true. And then block public policy equals true. Ignore public ACLs equals true. Public policy equals true. Ignore public ACLs equals true. And then restrict public buckets equals true. Okay, we have blocked everything on this bucket. And now DynamoDB table. What is DynamoDB table? This would be the last thing. Hello. Is the free tier of AWS enough for me to understand most of its services? I don't know much about AWS, but I have its free tier. Yes, I mean I had no idea about what even a instance is, EC3 instance is of AWS in at 1st of April, but now at 19 after 2-3 weeks of studying. Yes, it now makes sense. And the free resources are like, yep, totally enough. You get $120. Wait, how much resources do you have? You get $100. Everyone gets $100, but then I don't know why. Somehow they also added $20 more to my account due to some reason, and that is enough. Like totally cool. Yep, $20. Launch an AWS instance. I guess when you launch a EC2 instance, they just give you $20, which is pretty cool. What is this? DynamoDB. Okay, shit. This is database. When we have a wait, what? This is a database. DynamoDB is a AWS's managed NoSQL database, also a key value store like MongoDB, similar to your mental model of S3, but designed for fast structured data access rather than file storage. Okay, in the context of Terraform locking specifically, the DynamoDB table is used as a distributed lock. When a Terraform apply starts, it writes a record to the table. Okay. And the things that we define, and these are this: name, billing mode, pay per request is crazy, hash key, lock ID, type S. What are these options? AWS DynamoDB table. We are creating a DynamoDB table, but then why did we create this bucket when we are not giving anything related to the bucket here? Type S. Maybe this S thing is telling DynamoDB to use this bucket to store data. Yep. In the context of Terraform, specifically when another apply tries to run at the same time, it checks the table, sees the log exists, and refuses. Why DynamoDB and not S3 for the lock? S3 has no atomic check and set operation. Okay, this is a bit crazy. So now, will this DynamoDB use the bucket that we just created to store the config, and the DB is like a wrapper around the bucket which handles this thing that this was saying, which handles set and check, which gives an additional benefit of check and set question mark. No, shit, okay, they are different. They are completely separate AWS services that do not know about each other. Terraform just uses them together to perform operations. Wow, what is S3 being used for? What each one does independently. S3 bucket stores the actual state file. Here's the full state file of our infrastructure. Dynamo table stores only a tiny log record, one row. Someone is currently running apply. Okay. So this is to avoid race conditions. This is like mutex. DynamoDB is being used here as mutex. When we go into the critical section, we apply the mutex lock. Yes, exactly. Okay, cool. It is a distributed mutex specifically because the process is trying to acquire the lock can be running on completely different machines, your laptop, your teammates laptop, GitHub. Okay, cool, makes sense. So if there are two processes who are trying to get the state, this TS Terraform state, two people should not get access to this state at the same time because they might make different changes and there would be problems. So whenever a user gets access to the TS state, the user first checks this DynamoDB table. And DynamoDB is very like quick, and the user goes to the table and checks. You can think of this like there is a key in table, and the key is being used, and the value is a boolean data type. And whenever someone wants to access this state file, they go to the DynamoDB table and check that is being used. If it is false, then they will go forward and like get the access to this and also update the table here to make it equal to true. Is being used would become true, and then if someone else comes and they see that is being used is true, then they will wait till is being used becomes false, and when it becomes false, they will take access and do their thing. Cool. That makes sense. AWS, okay, that makes a lot of sense. AWS DynamoDB table, AWS provider. DynamoDB table as a resource here. Hello, yeah, I think they add more dollars based on different activities you do with that shit. Infinite money glitch. Shit, that is pretty cool. Keep doing CF problems. They will make you smarter, I guess, or not smarter, but they will force you to think, which is pretty cool. Okay, the phone is just not charging somehow. Mm-hmm. Mm. 1 second, let me just fix this. Debugging. I guess never mind. Faceless YouTuber. I will become a faceless YouTuber after this. And cool. Okay. DynamoDB. This is how we define DynamoDB using these terms: name, billing mode, provisioned, read capacity, write capacity, hash key, range. And here we can see what are the things which are necessary to make a table. Here, arguments, reference. This is required, hash key required, and name is required, and everything else is optional. Attribute, set of nested attribute definitions only required for hash key and range key attributes. Attribute, okay, hash key is required, forces new resource. Attribute to use as hash partition key must also be defined as an attribute. unique within a region. Name of the table must be unique within a region. Hash key and attribute. What is hash key and attribute in this? These are DynamoDB specific concepts of how it defines and looks up table. Hash key, the primary key. Okay, primary key from like SQL. This is the hash key. Okay, what's our primary key? Variable character. It is DynamoDB, which field uniquely identifies each record in the table like a primary key. SQL. Since we are creating a table, we are giving here the schema for the table, and we are saying that this hash key is going to be the field which defines which is going to be unique, So when Terraform wants to check if it is locked or not, it can look up the row lock ID and attribute the field definition. It defines the type of the hash key field. Attribute defines field name, lock ID. Okay, attribute defines the type. Okay, the type for this field is going to be a string. Okay, cool. Makes sense. Now, resource AWS DynamoDB table. The name is Terraform lock, and this needs a name. Name is going to be unique. Terraform state, Terraform DB, environment variable, hash, hash key, log ID, and attribute name for log ID. The type is string. Okay, in this part we created a bucket, and in this part we created a database. It's pretty cool. Shit, I guess you can drink coffee and get up. If you cannot run, then walk. If you cannot walk, then crawl. Like, stuff like that. And now perform plan to make a plan. And error, availability unsupported argument in availability region does not exist in main inside AWS provider line 13. Terraform init to install the provider. Shit, the provider exists already. Region, share, yes. Region equals AP South 1. Terraform plan, check out. And attribute is not supported. Did you mean to define attribute? Okay, shit. Okay, makes sense. Small n, Terraform plan, error, AWS DB bucket expected attribute to be one of k. Okay, still there is an error. Two errors occurred. Read capacity must be at least 1 when billing mode is 1. Argument is depreciated. Okay, we have to give in read and write capacity and billing mode. Billing mode optional controls how you are charged for read and write throughout throughput and how you manage capacity. The valid entries are provision and pay per request. What do they mean? What does pay per request and provision mean in AWS S3 bucket in AWS DynamoDB? What do these mean? Yo, hello, Amit Patel. How is it going? E per request. Look at this. P per request. This is a serverless billing option where you only pay for the actual request. Okay, serverless makes sense. Provision is in this mode you explicitly specify the number of reads and writes per second expect. Okay, pay per request would be the way to go in that case. We don't need per second thing. Pay per request. Terraform plan. Yo. Cool. Cool. Argument is depreciated. Which one? In this on bucket line 1 resource AWS S3 bucket Terraform state resource AWS S3 bucket use AWS S3 bucket versioning resource instead. Terraform plan. When we are doing this, we don't have to give in versioning, I guess. That was one error, unsupported block versioning and unsupported block server side encryption configuration. AWS bucket versioning, AWS bucket versioning. AWS bucket versioning, this is the one. Cool. And here, what are the things? Versioning configuration status enabled. Okay. Versioning configuration. Enabled is a string with capital. Enabled. And what else? We want encryption on this thing. Expect bucket owner. Wait, there is no encryption thing. We cannot add encryption here. We add encryption from here. A S3 bucket server side encryption. S3 bucket server side encryption provides a S3 bucket server side encryption configuration resource. Okay, destroying and this. AWS key MS key. Yep, this thing. Make a bucket and rule, provide a rule. KMS is, what is KMS? Some algorithm. This is the key. Okay, shit, this is the key used to encrypt bucket objects, deletion window in 10 days, my key to get a key, AWS KMS key, and AWS S3 bucket server side encryption configuration. The name of this configuration is example. Apply this to this bucket, and the rule is apply server side encryption by default, KMS key SSC algorithm, AWS KMS. KMS is an algorithm. We will use some other algorithm. AWS RSA key encryption algos given by AWS. Yo. KMS and AES. I guess AES might be here. AES KMS. Let's just use this AWS KMS key. Terraform state description KMS key. Okay, delete after 10 days. Okay, and then write AWS encryption, AWS S3 bucket server side encryption, AWS S3 bucket server side encryption configuration for this bucket. Block definition is required here. And rule, we have to add a rule. Yep. Apply server side encryption by default, that is the rule. Algorithm is AWS KMS algorithm, and the key is key ID is this. Cool. Will this work? This should work. This will create, yep, this will create all these things. Terraform plan, see if this works. This does work. Okay, note you didn't use the output. Terraform apply. What will this do? This will create a table, a DynamoDB table, a table inside this database, a key for the KMS algorithm, S3 bucket block access. S3 bucket would be created here, and this is setting the encryption setting for the bucket, and this is setting the permissions to access the bucket. Yes, set all of this up. How long has it been? 2 hours 28 minutes. Cool. This is doing stuff. Let's do a quick typewriter. Okay, shit, that is not quick. That is very long. That is very long. Hey, how was that? 78 is fine. Fine. Okay, shit. Error creating S3 bucket versioning for this. No such bucket. The specified bucket does not exist. Access denied for KMS key. Makes sense. Okay, shit. Makes sense. Makes sense. We have to change the permissions for this. Yo, down DMK. Yo, hello. Because we are using some AWS credentials, and the AWS credentials that we are using do not have complete do not have permission to create a bucket or other things database. The credentials only have access to, wow, is there some red there? The credentials only have access for EC2 instances. So we have to change the permissions. Users. This is lagging. Terraform. Add permissions. Add permissions. What are the permissions that we would like to add? Copy, attach policies directly. EC2 EC2 full access, Amazon S3 full access, and Amazon Dynamo DB full access. Okay. And next, add permissions, full access to EC2, S3, and DynamoDB. Cool, 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 cool. Yes, add all of this. Cool. Hello, sure, why shit, showing off your stuff. Shit, sure, why? If anyone else is there, I guess like sure, why you are the only one here. If there is anyone else, go subscribe to Shoravai because he is planning something crazy and like it will blow your mind. You will not even believe what he's planning to put on his YouTube channel. You should go and subscribe to him. Shoravai. No pressure. No pressure. He also has a YouTube channel and he's going to do crazy things on it. And bucket is stuff is happening. Still creating a bucket. Still create. Okay, why is it taking like this much time to create a single bucket? AWS is slow. Shit. Yes, indeed. And shit, you can like abuse now because you are a moderate, not moderator, but a member. Crazy privilege. Actually, can you write Heinrich Himmler? I don't know the spelling. Ah. Heinrich Himmler. I can write it, but I don't think you can. Heinrich. Spelling is wrong. Himmler. Shit. Heinrich Himmler. Fix the spelling. This is just not stopping. Shit. Okay, you can write it. You can write it. You have power. That is crazy. Parvai was trying to write Heinrich Himmler and he was not able to. HHSS. Shit. S3. S3. And it would be cool to see if this video is still monetized after sending these words. These like unacceptable words. No society would accept these words. Okay, shit. Error creating S3 bucket versioning for Terraform state. Hello there, walrus there state. No bucket. The specified bucket does not exist. It the bucket does not exist. That is why we are trying to create a bucket. Terraform plan, and is this okay? Nope, it is not okay. Versioning configuration in AWS blocks are not expected here. This okay. Versioning enabled. Terraform apply. Cool. Oh shit, no problem. Argument is depreciated bucket transform down. Only lowercase alpha allowed in this. Okay, makes sense. And why was there access denied for KMS? Shared access for KMS. We have to change access. The credentials which are being used by Terraform do not have proper permission to create a key pair for encryption. Users, this one, Terraform, add permissions, KMS, AWS permission policy to make a KMS key. What is the policy called? What is this? Allows the built-in this AWS to manage AWS key management service. Okay, cool. Yeah, is that is what we want. KMS, add this, add permission. Cool. And KMS permission is there. Cool. So now we have fixed this permission access, and then in here we have to change the name. Variables.tf. Walrus here with tf state and bucket. It should be cool. Terraform apply to make the changes. Yep, do this thing. Okay, shit. Okay, I guess it created a bucket. Access denied for KMS. Key creation, access denied, key creation. Shit. Yes, that is a I guess what do you call it? Common opinion, default opinion. That is what should happen to him. Add permissions, KMS, actions, encrypt, decrypt key, allow, copy JSON. How do we creation access AWS KMS create key. That is what is needed here. KMS allow the key create key is not authorized to perform KMS create key. No. KMS limited read and write. No, should we want full access to KMS? We want full access to KMS. How do we give this thing full access to KMS? Add permissions, attach direct permissions, key. Okay. There's nothing. That's KMS. Allow AWS user to create KMS key management service. Grant them a specific. By default, users do not have permission to create keys. KMS create key, but I'm intermediate using a custom policy or to successfully create a key through AWS KMS console. Additional permissions are usually necessary because the console performs multiple steps automatically. This the core action, but how are we going to give it permission? Navigate to the pane. Yep, add permission. AWS key management service power user. Okay, shit, that is the thing. Key management service power user. AWS key management service power user. What this does is provides access to AWS key management service. Okay, cool. Power user. Cool. Next. Add permission. Now we won't get the error. Let's see. Also, the phone is going to die in a bit. Somehow it is not charging. Okay, cool. This created a bucket. And stuff. Pretty cool. Okay, it is now trying to charge. I guess I need a coffee or tea. Yep, you do, I guess, because you are feeling sleepy. You know something, it is best to accept your emotions and say, well, I feel how I feel. Well, no, well, not always, because sometimes you have to man the fuck up and you cannot just say, well, I feel how I feel and it is okay. But yep, sometimes it is necessary. You have to say when you are like deep in depression. I feel how I feel. Okay, so we created the key. Okay, we created an AWS bucket and also this paper request your project Terraform lock name and everything. Now cd bootstrap init apply. We did that. Now configure your main infrastructure to use the bucket as backend. Okay, what does that mean? Terraform backend S3. Oh, that makes like so much sense. That makes so much sense. Okay, adding backend to Terraform means Terraform will be using it as for storing. You cannot fight. Yep. So sometimes you do have to say share. That is what you said. Sometimes, not always. The thing is that you can man up at the same time as accepting your, yes, yep, sometimes accepting your emotions is being man. Backend blocks Terraform from where to store and retrieves. The backend block tells Terraform where to store and retrieve. Okay. S3, use S3 instead of local storage. Okay, store it at this path in the bucket key region. Okay. Terraform backend with the S3 backend. Okay, these are the things that we need to give. Where to store the state? Bucket. Encryption, true, option, region, and key. Okay. In this, what should be added to the backend config? Also, like emotions can serve as useless sources of information. If you deny them, then you, yeah, okay, you did say useless. If you deny them, then you are denying information. Useless or useful? I guess you wanted to write useful there. I mean, yes, everything is a source of information. Anything at all depends on what you consider to be information. Based on your resource, the backend configuration should be like this. Create a S3 bucket, your env value cannot be used here, makes sense. Key, the file path, and DynamoDB env value, KMS key ID, KMS key ID. Doesn't work because the backend block is initialized before Terraform loads variables. Okay, you cannot use variables. Okay, makes sense. Hard code the values. Option 2, use partial. No. Bucket makes sense. Use this bucket, which is unique name for the bucket. Region, DynamoDB table. Okay, and a remote backend for this. Terraform automatically does the mutex thing with the DynamoDB. Okay, cool. We need to give in bucket in our main Terraform config file. Substitute in the whole file, substitute dollar, like a literal dollar, and then this var.env with this. Remove this. Cool. Terraform apply, to apply this. No changes. Cool. Nothing was changed. Now infrastructure Terraform. In Terraform, we have to define backend is S3. Bucket, key, and region. Region is this. Cool. Key is this. And bucket is this. What is key? You also have to give this. Infra Terraform Terraform.tf state. Bucket name is not this. Bucket name is not this. Region is right. DynamoDB encrypt true. DynamoDB URL and the bucket name are the two things remaining. Bucket.tf inside main. Name of the bucket. Cool. Okay, that should work. That should work. That should actually work. Terraform init. Shit, no. Are there any Terraform things here? Oh, good. Nothing. Terraform init. DynamoDB is not expected. DynamoDB table. DynamoDB table. Terraform init, that should work. Okay, what this will do is, do you want to copy existing state to the new backend? Yes. Okay. And if we go to our AP South AWS instance, and that should have created a bucket. S3 bucket. There is an S3 bucket with the given name. Inside infrastructure, inside Terraform, we do have Terraform dot something. Cool. Okay. Git push origin main. Okay. Okay, cool, cool. This should work. This should like actually work. We'll see. CI/CD pipeline is running. Yes, two things. Actions, fix CD. This thing push image is running, and after that pull will run. While that happens, we can play a game. Cool. She was a genius of sadness. Not too good, not too good. Yes, 69, very bad. I mean, 69 is not too bad. Cool. And about this, okay, okay, pull and run is running. Yep, makes sense. Why did we get error? Wait, should we got error? Yo, let's go. SSH host, no such host. Okay, Terraform is working completely fine. We got error in the SSH part, which is very good news. Here, we got error here. We are defining SSH variable here. How do we get access to this variable later on? I am defining this SSH host variable in one step. Then why am I not able to access it in the next step? Same issue as the CD problem earlier. Shit. Don't do this. There is a default thing that we add. Defaults with default run working directory is wait, but why? This writes it to a special ch action file. Now steps dot terraform, a terraform step. We give this thing an ID dot outputs from this. The SSH output is what we are looking for. Auto approve. We don't need this. Infra terraform give this an ID. Steps dot terraform dot outputs dot sh host. Git commit, git push origin main. Cool. Okay, that will start the workflow again from scratch. Here it is running. Push image, yep, there is no problem with this. It will just run. In that time, we can do another type laser. I think if there is someone in the chat like who would like to do a race, I think we can quote of quote of the day. We can do this. Create a race track and do race with each other. What is bro doing? We are doing a race here. Do you want to do a race? I should make coffee. Coffee, you should make coffee, or to make coffee you would have to order coffee, for which you can do this. Yes. Yep. Terminal.shop, you can go there and order coffee from your terminal, which is like pretty cool. We can do this on quote of the day. Okay, shit, that's cool. Shit, that was not very good. You should make coffee. Okay, push images, almost done. Yep, done. Now pull and run. We were not able to get. Okay, Terraform setup completed. Terraform changes, initializing the state, Terraform state, Terraform initialized, acquiring log state. Cool, cool. So that we do not do things which already have been done, like json.log file. No changes. Okay, infrastructure is pretty cool. Outputs, we got the IP address, but there was an error in GitHub Actions, missing server host. What does that mean? Missing server host. Missing server host. Host was not provided. Host is like literally provided here. Steps.terraform.output.ssh host. Shit, output this to GitHub output to this file. Okay, cool. Echo this thing to here, GitHub output. Like this, GitHub outputs ssh, get the key. Cool, ssh, GitHub outputs, outputs, not ts, GitHub output. Cool. Git add this, git push origin main. Cool. This will start. Wait, I guess we should like not run Docker when it is not doing anything. Cool, this is running, and I guess we have a lot of commits today. just for fixing stuff. Yep. 11, yeah, 11 is fine. Wait, there were 16 at one point. 31 commits. That is crazy. 31 commits. Cool. Let's do type racer. If anyone wants to do this on like a personal racetrack, we can compete. Looking for opponents. Still happening. Good. Not very good, not very good. Okay, this is running Terraform. And it has been 3 hours. SSH part, we were getting error in SSH. Now let's see what do we get. We are not getting error in SSH. Okay, that is like so good. That is very good. Everything is combined. That is so good. That is like very elegant and beautiful. So what is the case now is AWS. If you go AP South here, this is starting up a new instance, I think. Wait, shit, why are there 2 instances running? We will destroy them. Okay, and if we go to Walrus codes, we are not able to go there because walrus.codes is pointing to an old instance which is not running right now. Actions. How do we delete an instance? Instance state, terminate. Now terminate the instance. Pretty cool. Now the cool thing is, I'll show you. Okay, these instances are turning off now. Terraform, if we Terraform destroy everything, yes, remove everything, literally everything. Instances are terminated. Cool, everything is destroyed. So there is no AWS instance which is running right now and hosting the backend and the front end. These are terminated, but we just have to do one thing. We can rerun this job. Rerun job. Okay, both of them will rerun, the push image and also the pull image, which is not very cool, but yep, because this is very time consuming. This will take like 1 or 2 minutes to complete, and when that is completed, this job will end run. Okay, we'll wait for this one to run complete. Cool. That is like very cool. And in this whole infrastructure as code, we never had to SSH into the machine. We never have to SSH into the machine itself. So that is like very, very cool. And apart from that, I guess there is one more change we will have to make in our Terraform, which is certificate. We don't want HTTP, we want HTTPS certbot. We can use certbot for certifying and getting a certificate. You need a certificate if you want to run an HTTPS site, which we can get using certbot. And we are using the software is Nginx, and the system is Linux Snap, I guess. Then these are the steps. Install certbot, do this, certbot, with Terraform. This is still running. Pull and run. Okay, we are on the next step. Terraform. Okay, Terraform is saying that all of these things will be created. That is like your EC2 instance and everything will be created, and it is now creating all those things. Pretty cool. Using certbot with Terraform typically involves one of two approaches, either installing and running the certbot CLI on managed servers, or more commonly replacing the certbot CLI entirely with Terraform ACME provider to manage certificates as native. Okay, sure, ACME provider, which is recommended. Instead of installing certbot software, you can use this provider to handle automated certificate management. ACME protocol. Let's encrypt. Used by Let's Encrypt. Wait, Let's Encrypt is a thing. Let's Encrypt is a certificate authority that provides free TLS certificates, making it easy for websites. Okay, and they provide their own provider for. Okay, shit, we got an error. Connection refused. SSH connection refused. SSH connection refused. This is the place. This is the URL. SSH connection was refused. The key is right. Yep. The key is /.sh/AWS. This is the key, and Ubuntu is the username, and this is the IP address, and the port is 4321. Okay, we are able to SSH here, but not there. Why? Because it takes some time. If we rerun this specific job now, it will run. Rerun jobs, rerun failed jobs. Yep, rerun this job, pull and run, and it will run this time because it takes some time. It takes some time for the port or for the configuration on the server to like get started. Refreshing state. No changes need to be made. Cool. Public IP is this. SSH, and this time SSH works. This time SSH works because it takes some time. Okay, how do we add this like little delay? Terraform for initializing an AWS instance, which an AWS instance which installs Docker and changes SSH port, but this takes a little time. Why is there like a cross there? But this takes a little time, and I want to add a delay between the Terraform step and SSH step in GitHub. Wait, shit, we can just literally add a delay. I think there is a sleep command. Yep, sleep, just sleep. Sleep 2 minutes, sleep for 2 minutes. Yes, we can add a delay. Let Terraform finish, run, sleep for, let's say, 3 minutes. That should be good enough. Terraform destroy everything. Yes, cool. Yep. I guess that would be the recommendation. You can simply add a sleep. Yes, exactly. Added ACM has been 3.5 hours. Cool. This is destroying everything. Cool. Everything is destroyed, and if we just go to GitHub and nope, rerun all jobs. No. Rerun this job specifically. Attempt to rerun. Yeah, rerun jobs, full and run. Cool. Rerun this job. Wait, this is not rerunning the whole. Yeah, this is just rerunning this job with Terraform. ACME provider. ACME provider, the automated certificate management provider. ACME is an evolving standard for automation. Domain validated certificate authority. Clients register themselves on an authority. Okay. How do we use this? In Terraform, we require providers ACME as a new provider with a version, and then provider ACME server URL, which is this, and then a resource RSA email register account PEM key private key resource. Okay, we will add this at some point, but right now shit, Connection refused. Of course, connection refused. Of course, shit. Of course, connection was refused. Terraform destroy because the sleep command is in the latest GitHub commit, which is present locally but is not available here. We have not pushed our code. Let's do a race while this is destroying. We will destroy our opponents instead. The incomplete something. Yeah, that was very bad. Okay, the thing is destroyed now. This will run with a delay. 99% of the GPU is being used. That is crazy. Brave is using like literally 1 GB of RAM. Easy stuff. While Windows server thinking so much. Cool, and that would be cool when this works. This is just building the new Docker image and pushing it forward, and this will take some time to do. And one more thing that we have to do is this. EC means certificate and account provider to get HTTPS. This is now pushing the layers, and we are almost done with this, and we are done with this. Now the pull and run step. This will also take long because this will create a new container, which takes time, and not just a single container, but more things than a container. Yep, all of these things. Okay, AWS key and all that. Cool. Pretty cool. And when this is done, everything would be done except for we will not have the SSL certificate. Yep, this will just wait for 3 minutes now. We will not have SSL certificate, which is like, wait, SSL or what? Secure shell layer certificate for HTTPS, and we will not have a way to make our domain walrus.codes always point to the latest IP, which we will have to fix. Yep, but for now this is good enough. And also there are bugs in the main application. There are bugs in the main application which we have to fix. Let Terraform finish. Cool. This will just like wait. The command that we ran is sleep for 3 minutes. It will just sleep for 3 minutes. That is crazy. This is from Civilization 4. Shit, that is crazy. This is from Civilization 4 game. Okay, it is still finishing. Is Civilization 4 free? And we don't actually have to open Steam for this. We could have checked in the database. steamdb.info. Wait. It is still finishing. Civilization 5. Sid Meier's Civilization 5. That is shit. Okay, shit. Its lowest price was 149 in India. And in Indonesia, it costed like less than 1 rupee at one point. That is crazy. And right now it costs like 1000 rupees. Okay, cool. Full complete and everything. Okay, it is just running. Cool. Right now it costs 1500 rupees. And Civilization 3 Civilization Beyond Earth 3 complete. That is also 250 rupees. That is fine. Cool. And yep, this was done. Yep, this was done. If we go to the URL, to the IP address defined in here, set up Terraform changes here, this one. Yep, in the this website. Cool. This was deployed automatically, which is pretty good. And that would be it for now. In this stream, what we did is we added Terraform into the project itself, which is pretty good. And why we needed to do that? We needed to do that to get IP address for the current instance which is running. So pretty cool. And that would be it. And thank you for being here.